Let's break down the steps that we're going to be taking in this module to build that functionality. So we're going to start off by adding an enemy sprite. We're just going to use a graphic and animation like we did before, and we're going to create a new sprite for an enemy in our game. Then we're going to need to have some intelligence for this enemy. So we're going to implement our artificial intelligence as a component, just like we did with gun. This will make it so that our artificial intelligence is reusable if we had more enemies and we wanted to apply that same artificial intelligence. And it's also going to help us separate that functionality of the thinking or the brain of the alien or enemy sprite into the place where it belongs, not all mixed in with the enemy sprite. Then we're going to be adding some simple movement. So we'll have our AI component, but we need to add some logic to make the enemy move. So we're just going to implement a way of getting that enemy to move to the left and to the right and to make that somewhat random. As we'll talk about in a little bit, randomness is a really important component of artificial intelligence, at least in games. Then after that, we'll add the ability to shoot. So we'll make it so that the enemy, when it detects it's near the player, fires, and it'll have the same firing restrictions as the player. But we'll also be reusing that gun component, and we're going to have to make a few modifications to do this, but you'll see the power of using components when we get to that step. After that, we will handle enemy kills. So when the player shoots an enemy and that shot comes in contact with the enemy, we want to be able to kill the enemy and get rid of that shot. We're going to implement that logic using something called collision detection. Then we're going to implement the same thing on the player side. If the player gets shot by the enemy, we want to detect that condition and we want to kill the player, and that will end the game. And then that brings us to our final step, which is we're going to add a game over screen so that when the player or enemy is killed, that will end the game, and then a player can restart the game by clicking a button on that game over pop-up that will show up. Okay, so let's go ahead and start off by adding our enemy image. We're going to create our enemy sprite. We need to have an image first. So I've got this Alien 2 PNG that I created, and you can see here that it's got the 4 frames just like before. And I used a pixel editing software to do this. It took some time to create this, but I was pretty happy with the outcome. If you're willing to put in the time, you can come up with some really nice looking pixel art. I'm no expert at pixel art by any means, but I was happy with the results I got from this. So after we have that, then the next thing we need to do is add another data file. So let's go ahead and copy one that we have. So let's go ahead and rename this one, and we're going to call this one alien.json. Okay, now inside here we need to make this be correct for the alien PNG. So this is going to just depend on what your graphic is, but in my case we're going to call this alien, and the tile width is going to be 156, tile height is going to be 60. We're leaving SX and SY the same. The width for the entire image is 312 and the height is 120. And again, make sure that you get these exactly correct, otherwise you'll have some problems. So then the next thing that we need to do is we need to load up these graphics and then our data file so that we can get our sprite sheets. So let's go ahead and go down in here, and remember that we need to do this load. So let's go ahead and load our new PNG, which is going to be this alien2.png. And then we're going to load up a new JSON file, which will be our alien.json. Now then, and let's make sure that we have this spelled correctly. That's one small problem with a JavaScript framework like this. If you're used to using C# or Java or something to do game programming, you get a little bit more static typing, so you know if something's wrong. Of course, with a file name, it's still not going to fix anything for you, but it is important to realize that when you're working with JavaScript that you do have to be a little bit more careful. So let's go ahead and add a compile sheet for this as well. So we're going to make sure that this says alien2.png, and then for the JSON file, this is going to be alien.json. And while we're at it, we should probably add our animation. So I'm just going to go ahead and copy this one, and we're going to make this one be an alien animation. Okay, so now we're all set to create our actual alien sprite. Okay, so now let's go ahead and create our enemy sprite. So we're going to do this just like we did the other sprites we've created so far. I'm going to create this right underneath our player sprite. So we're just going to do a Q sprite, and then we're going to do .extend. And again, make sure that you have sprite, not sprites. And then we want to name this alien. And then inside here, we're going to set up some of the defaults. So first, of course, we have our init. And then we'll make our function p inside here. And then inside our init, we start off by doing this _super, pass in p, and then we'll go ahead and pass to this constructor where we're going to initialize our alien with. So first of all, we're going to use a sprite, and it'll be the alien sprite. And then we're going to say what the sheet is, which is also called alien. Then we want to position this alien on the screen. So let's do x equals to q.el.width divided by 2. That'll center it from the x perspective. Okay, so then for the y value, we're not going to put this here. Let's go ahead and add our speed, which will be 200. And then right after this, we're going to do a calculation. So we're going to say that this.p.y is equal to this.p.h. So this is going to make sure that he's at the right point on the screen. If we just left it at 0, for instance, that would be the center would be at the top of the screen at 0, which would make half of him be off the screen. If we do the height, it'll give us a little buffer, so it won't be right at the top of the screen. So this is a pretty good place to put him. And then remember, we need to add animation, so we're just going to do this.add animation, and now we'll have that animation component, and then that gives us the functionality to be able to do this.play, which we pass in the default. So we'll have default animation. And at this point, that's all we're going to be adding to our enemy sprite. Let's go down in here and we'll insert him into our main level. So we'll just do stage.insert, and we'll do a new q.alien. Okay, now we should be able to run this, and we should see our alien show up and not really do anything. So he's just sitting there animating, popping his head up and down out of that window, glaring at us. And that's it for now. So now we'll need to actually start implementing some artificial intelligence and make it move around and shoot, but we'll be doing that next. Now, one really important thing too, just about any game that has a computer-controlled character, is artificial intelligence. This is something that a lot of beginning game developers get wrong, because what you would think would be the best way to implement artificial intelligence actually isn't. So let me tell you the mistake that most people make when they first get started out. I made this mistake myself, which was to make it so that the enemy is too smart, so it does everything right. I'll give you an example. I've created a Pong game before, and when I was first learning to create games, I implemented the artificial intelligence for the Pong paddle, for the computer paddle, to always move where the ball was. Well, you know what? That game wasn't very fun at all, because the computer never lost. It always hit the ball back. What I ended up doing was making it so the computer was a little bit dumb. So it randomly made some decisions that weren't quite right, or it had a random delay, so it didn't quite react as fast. And I made all of this random. And that's the key to artificial intelligence. So you'll find that in order to make good artificial intelligence for a game, you need to make the enemy somewhat smart, but you have to give them some randomness to their actions so that they're not always making the best decision. They're sort of following a guideline or a plan, and sometimes that plan is going to have random elements dispersed in that. That's going to make the enemy seem a little bit unpredictable, and is going to not make them boring to play against, where they just continually beat you and beat you. Okay, so in our game, we're going to start off with some really basic AI. But before we can actually implement the AI, we're going to create an AI component, and then we're going to add our logic to this. So we're going to create an AI component in a similar way that we created our gun component. In fact, I'm just going to put this right here after our shot. We're just going to say q.component, and then we're going to call this basic AI. And this is pretty neat, doing things as components, because what we could do is we could make multiple kinds of AI, and we could swap those out and have maybe different stages that where the computer or the enemy would have a different AI. But in our case, we're just going to create one for now. And what we're going to do with this basic AI is we're basically going to make it so that the AI knows how to move and then how to shoot. And we're just going to add this functionality one piece at a time. And we're going to start off with moving. So in order to move around, what we want to do is, like I said, we want to make things somewhat random. So what we're going to do is we're basically going to have the computer switch directions from left to right, and it's going to do this at a somewhat random interval. We're going to say every 1 to 5 seconds, it's going to change directions. And like I said, this is going to be a very basic AI. It's not really going to have any smarts as far as the moving goes. You could make it so that the AI follows a player around, but that would be kind of boring as well unless you added some randomness to this. But in our case, we're just going to make it so that we just change directions. Okay, so let's add some basic AI for movement. So what we're going to do here is we're going to add this added function. This is going to be called when this component gets added to our sprite. And what we want to do in here is we want to do this.entity, and we're going to say change directions. And we're going to start off by changing directions, and we're going to make this function that's going to basically change the directions, and then it's going to set a timeout to call itself again to change the directions again from 1 to 5 seconds. We'll make a random choice on how long it'll wait. Then the other thing we're going to do is we're going to add some movement. So we're going to say, okay, every time that step is called, we want to move. So we're going to do entity.on step, and then we're going to say call this move function that we're going to be creating. Okay, so now let's go ahead and create those functions that we're going to need. So remember, we do this extend. This is going to add these functions to whatever class is going to have this component, or whatever object is going to have this component. So let's go ahead and go to change directions. And what we're going to do here for change directions is we're going to create a new function. And inside this function, let's do our var entity equals this. And then we're going to figure out the number of seconds that we're going to wait. So let's do a var number of seconds. And we're going to set this equal to math.floor. And then we're going to do this math.random, and then times 5 plus 1. So that's basically going to give us a number from 1 to 5. This is how you create a random number in JavaScript. And then we're going to do a set timeout, and we're going to do inside here a function. And inside here, we're going to, when this timeout gets called, we're going to change the speed. So we're just going to go the opposite direction. We're going to do entity.p.speed, and we're going to say this is equal to negative entity.p.speed. So effectively, it will change directions from left to right or right to left. And then we want to go ahead and call our change directions again. So we're going to do entity.change directions. So once we've actually changed our direction, we're going to recall this again, which will set the timeout, and this will just keep going. So the enemy will keep on moving back and forth. And then what we're going to do is take our number of seconds times 1,000, so that this is going to be anywhere from 1 to 5 seconds. Our enemy will switch directions. Now the next thing that we need here is a move function. So let's go ahead and add that as well. So we're going to say move, and we're going to create a function. We're going to take in dt here. And then inside move, we just need to move our enemy. So we're going to do this just like we did with this shot. We're just going to say, in fact, let's do a var entity equals this. And we're going to say inside here, entity.p.x minus equals entity.p.speed times dt. So remember, we're going in the x direction, so we'll just be subtracting from that. And if our speed is negative, we'll go the opposite direction. So this will work regardless of what direction that we're headed. And then we're going to do inside here a little check to make sure that if we hit the wall, we bounce back the other direction. So we're just going to do this like this. We're just going to say if entity.p.x is greater than q.el.width minus entity dot p dot w divided by 2. So just to explain this, we're basically saying, okay, if the x position of our entity is greater than the width minus half of the entity size, because remember that's the center of it, and we're always talking about the center, then we're at the edge. So we need to turn around. And then we're going to say, or entity dot p dot x is less than 0 plus, and again, we'll do entity dot p dot width divided by 2. So if we're at either end, then we're just going to turn around. So we're just going to do entity dot p dot speed equals negative entity dot p dot speed. So we effectively, if we bump into a wall, we will switch directions. So now the last thing we need to do is to add this to our actual alien. So we're going to go ahead and do this dot add, and we're going to add basic AI. Now we'll have that component, and all that functionality should just work. And before we run this, let's just check everything to make sure we've got all the right references for entity. Looks like this one should be this, because this is on the added. Remember that you have to use this. It's a little bit different because what's happening with between added and extend, this is a little bit of a confusing point. When you do extend, these functions get added on to whatever you're using the component with. So this would be added onto our sprite. So the this in here is actually referring to the this of the thing that this is added on. In the added, this is operating inside the context of the component. So in this case, the component stores a reference to the entity that it's operating on, and that's why we have to do this.entity. Okay, so let's go ahead and test this out. We're just gonna run our program, and now you can see the alien ship it's going around here, and it's moving randomly. Now we can't kill it, but you can see it'll never get stuck on a wall, and it's just sort of randomly moving back and forth. It seems like a pretty decent AI, and that's the key to AI, like I said, is you want to make it appear as random as possible within the strategy that you're implementing. So because he's moving back and forth randomly, it kind of looks like maybe is he tracking us? We're not sure. But this makes it a decent AI. If you can imagine, if he were just following me wherever I went, just like a shadow, it wouldn't seem very intelligent, or it wouldn't actually be very fun, because you could just predict his movements. Now the next thing that we're going to do is add the capability to fire. We're going to add this as part of our basic AI. So in order to do this, we're going to reuse the gun component. But let's go ahead and start in our basic AI. And what we're going to do here is we're going to basically make it so that on every step, the enemy is going to try to fire anyone using this basic AI. So we're going to do this entity on, and we're going to say step, and this time we're going to hook up try to fire. So every time they're going to try to fire. So we're going to need to create a function try to fire. And let's go ahead and make this try to fire. It'll be a new function. And inside here, what we want to do is we want to have some kind of strategy for firing. And we're going to make this fairly simple. We're going to figure out where the player is and where we are in relation to the player. So we're going to say if we're within the width of the player from their center on either the left or right, so we'll basically have this field that'll be double the size of the player, then we're going to go ahead and try and fire. So we're only going to fire when we're near the player. So in order to do this, let's go ahead and grab our player. And we're going to use this jQuery-like syntax to select the player. So we're going to do Q player, and then we're going to do first. So we're going to get the first player sprite, the first sprite that matches that. You can use this selector to select different game objects inside of your game, which is pretty useful. Now we want to check to make sure we got a player, so if not player, then let's just go ahead and return. So if we've got our player, then what we're going to do is we're going to say if player dot p dot x plus player dot p dot w. So that's going to be the center of the player plus their width. If that's greater than this dot p dot x and player.p.x minus player.p.w is less than this .p.x, then we're going to go ahead and try to fire. And we can replace our thises with an entity if we want to. Let's go ahead and do that. Var entity equals this. Just to make things a little bit more clear about who we're talking about. Okay, so in that case, what we want to do is we want to call this .fire. Now we'll need a gun, so let's go ahead and add our gun. And we'll have to make some modifications to this gun as well. But for now, let's just do this .add gun. And then we're going to change it so that our firing is going to work for an enemy or a player. So we're going to make it so that our fire function actually takes in the type of sprite. So we're going to say QSprite enemy because we have an enemy sprite here. And then that's how we'll differentiate between the two types of firing that we're going to do. So let's go ahead and implement the functionality changes to the gun component next. Okay, so in order to reuse our gun component, we have to make a few changes to make it so that this gun will handle the two different types of shots. So right now we're going to be passing into our fire the actual type. So let's go ahead and add that type here. And then what we want to do in our handle firing is we don't want to have the inputs, the fire inputs, cause us to fire if we are an enemy, if we're not the player, basically. So the way that we're going to do this for now, we're just going to check. We're going to say if the input is equal to fire, and we're going to check the type. So let's do entity dot p dot type is equal to q dot sprite friendly. So if this gun is attached to a friendly sprite, we'll assume it's the player and it's okay to shoot. And when we shoot, in this case, we're going to pass in the type of friendly. So we're going to make some friendly fire. Now, the next thing that we'll need to do is to make sure that in our actual fire that we have two different ways that we create our shot. It's basically going to be the difference between our speed and then the type of shot. Right now, we're always firing friendly shots. So what we can do inside here is we can just do a check, and we can just say if our type that was passed in is equal to q.sprite friendly. So if it's a friendly fire, then we're going to go ahead and do what we're doing right now, which is to set our shot equal to the speed 200 and friendly. And let's go ahead and move this declaration outside here. So we're just going to do a var shot, and then we'll initialize it here. Otherwise, let's go ahead and put an else condition. Let's say else, let's make it so that our shot will be an enemy shot. In this case, this will be q.sprite enemy. This way we can use this a little bit later on when we use the collision detection, and we can make the speed be -200, and then our positioning is going to be a little bit different. We still want this to be in the center of our entity, but we're going to change this so that our y value is going to be, let's go ahead and do something like add the height. So we'll say entity.p.h, and then we'll subtract 20 from that, and that'll put it right about the right spot for our alien ship. Now, depending on what graphic you have or you're using, you might have to adjust this a little bit just to figure out the best place for that shot to show up on the screen. Now, our timeout and everything should still work as before. It'll function when the enemy has a gun. And now that we've made it so this AI is going to add the gun component, basically a chain of components here, we should have it so that our enemy should shoot. And before we run this, let's just check everything here. Let's make sure we have entity. We want to add the gun to our entity, and everything looks pretty good. And let's go ahead and run this and see what we get. So now if I bring this browser window over, you can see that the enemy is now shooting, and those shots are appearing when it gets within range of the player. So it would normally hit the player. So this is a pretty primitive AI, but it works. Even just a simple AI, for the most part, those shots are going to line up with the player, and it looks like the alien ship is shooting at the player. Now, the next thing that we're going to need to do in our game is to start handling collisions. Right now, the player can shoot, the enemy can shoot, but their bullets don't actually affect each other. If we fire at the enemy, it doesn't die. If the enemy fires at the player and hits the player doesn't die. So in order to be able to handle those cases, we have to do what's called collision detection. Now, Quintus is automatically going to do some collision detection for us, but I want to explain the basic concept here. So you can see in this picture that there's two boxes, and these boxes represent our images. These are called bounding boxes. This is a simple way to do collision detection. It's basically when the bounding box of one thing intercepts the bounding box of another, so these rectangles overlap, then that's a collision, and so we can respond to that collision. In a collision, there'll be two objects, and we'll have some information about the speed that those objects were traveling. If we were simulating a game that enabled physics, real-time physics, but we're not actually going to have physics in our game, so it's going to be a little bit simpler. We're just going to say, if these things intersect, then we have an interaction between these two, it's a collision, and we should do something for that collision. So for instance, when the enemy and a player shot intersect, then we're going to kill the enemy, we're going to get rid of the player shot. The same thing when the player and the enemy shot intersect, we're going to basically remove both of those. So we need to implement this collision handling inside our game next in order to be able to do those things. Okay, so let's start off by making it so that an enemy can detect when it needs to die, when it's been shot. And the way that we're going to do this is we're going to go to our alien sprite, and on here, what we need to do is we need to call something in our step, this.stageCollide, and pass in ourselves, and it's going to tell us if there is a collision. And if there is, it's going to basically fire an event called hit, and it's going to pass us some information about the collision, what it collided with. This is sort of a roundabout way to do this. It's basically making it so that we don't check for collisions unless we want to. So it gives us a little control over this. If you don't check for the collision, then you're never going to get hit fired. So what we want to do here is add a step function, dt. And the reason why we're adding it here on this alien sprite is because if we added it to, let's say, the AI, it wouldn't make a lot of sense. The sprite itself should know when it's hit. It's not really part of the artificial intelligence to be smart enough to know when you're dead. This is going to be a pretty common thing for a sprite. So that's why I'm adding it here. So we're just going to say this.stage.collide this. So it's just going to check the stage to see if anything is colliding here. And this is where the sprite types are really going to come into play for us. So one thing, remember when we did our background, we said the sprite none. If you didn't make the sprite none, you're going to see collisions just happen all over the place because our ship and enemy would collide with the background. So this is really critical. Make sure that you have that. This type is going to be used to determine whether or not a collision has occurred. So now let's go back to our alien, and we are going to detect collisions, but we want to go ahead and respond to this event. So we're going to say this on hit, and then we can just declare a function inline right here. We're just going to do function, and this is going to take in a collision, which will give us our collision information. Okay, and then inside here, what we want to do is we want to check to see if we've been hit by a shot. Now we know that we've been hit by a shot because we can't collide really with anything else here, but it's good to do a check in case we had other types of objects that could be collided with. So we're going to say call obj. Obj is going to give us the object that was collided with, and we're going to say is a shot. So if it's a shot, and we need to make sure that it's the right kind of shot. When our alien begins to shoot, we don't want it to instantly die from its own shot because it'll actually be in proximity to collide with it. So we're going to say call.obj.p.type, and we're going to and this against q.sprite.friendly. So if it's a friendly shot, then what we're going to check is if it's equal to q.sprite.friendly. And what this basically does for us is it makes sure that this is only going to be true if it's friendly. Remember, what's going to happen with these types is that you can have multiple types applied. Remember when we created our shots here, we said sprite default or sprite friendly. We gave them those two types. So we have to get this out of the bit mask. So we're doing a little bit of bit logic here. We're just, if you and the type against the thing you're checking for, if it's equal to the thing you're checking for, then you know that it's true, that it has that flag set. So if that's the case, then what we want to do is this destroy. We want to get rid of ourselves, kill the enemy, and then we also want to do call object destroy. We want to get rid of the shot as well. And remember, the shot's going to clean up itself because we have that implemented in the shot logic. So let's go ahead and give this a test, and we should see now that we can shoot the enemy. So the enemy can't hurt us, but if we take a shot, boom, the enemy dies. Let's go ahead and reload this again, and we'll see here if we can get a shot off. Boom, the enemy dies. Okay, now let's flip it and let's make it so that the player can get killed. So we're going to do pretty much the same thing. We're going to go to our player sprite, and inside here we're going to add this .stage.collide, this. Then we're going to make it so we have our hit. So we're going to do this on hit, and we'll just add a function inline here. We're just going to do function that takes in a collision. And then again, we're going to do our check. So let's do if call.obj is a shot. And this time we're going to make sure that it's an enemy sprite. So let's just go ahead and copy what we had here. And we're going to check so that it's sprite enemy, because only an enemy sprite should be able to kill the player. Then what we'll want to do inside here is we'll want to go ahead and do this.destroy and then a call.obj.destroy. Pretty simple. So let's go ahead and test this out. If we run our game now, and bam, the player dies. So the last thing that we're going to do in our game is we're going to add some basic UI. We're going to make it so when the player or enemy is killed, it'll end the game. We'll show a little user interface that'll have a button that you can click to restart the game. Pretty simple, pretty basic, but it'll demonstrate how we can use UI inside of Quintus. Now, Quintus does give us this UI framework. So if we do this include UI, now we have access to this UI module, which is nice because sometimes it's difficult to add things like user interface elements like buttons and text to games, but this makes it pretty simple. So what we want to do is we want to define here a new scene. So we're going to do q.scene, and we're going to call this end game. And then for this scene, we're going to add our function, and we'll take in a stage. And so what we want to do here is in our scene, we just want to show a little box that is going to say that the game is over and give them a button to click to play again. So we're going to create a container. We're going to say stage.insert new q.ui.container. And then in here, we can initialize our container. So let's go ahead and add to our container. What we're going to do is we're going to say that the x for our container is going to be equal to q.width divided by 2. That'll be the x position of it. And then for the y, it'll be q.height divided by 2. And then we're going to specify a fill for it. And we're just going to make this container be white. So we'll just do FFF, FFF. So that'll be our main container. Inside our container, we're going to add a few things. So first, let's create a button. We're going to set this equal to container.insert. And we're going to say new q.ui.button. And then we're going to pass in some initialization to this button. So we're going to set the x for the button to be 0. The y will be 0. The fill for this one will be a gray color. So we'll just do this like this. We'll do pound CCC, CCC. And then we're going to make the label for this button be play again. So that'll be our button. And then we're going to add some text to our container. So let's go ahead and create a text component. We're going to do container.insert, and we'll do a new q.ui.text. And here we're going to actually take some text that's passed in to us. For now, let's just go ahead and initialize this as it is. And inside here, we're going to say that the x value for the text will be 10. You could figure out the exact center of this if you want to, but this will be pretty close since it's going to be a small amount of text anyway. And then we're going to say that the y is -10 minus button.p.h. So we're going to make sure that this is not directly over the button. It's going to be above the button. Then we're going to add a label for this. And this label is something that we're going to pass in. This is going to come from stage.options.label. So we're going to actually pass this in when we set this stage. Then the last thing we're going to do is we're going to do a button.on, and we're going to say on the click event, then we want to do this function. And let's declare the function. So when someone clicks a button, we want to do q.clear stages. This is going to make sure that all the stages get removed if you had multiple stages. And then we're going to do q.stage scene. And we're going to go back to the main level. So that'll effectively reset our game. Okay, so now let's go ahead and make it so that we call this. So there's a couple places that we want to do this. If the enemy dies or if the player dies. So let's go up here and find for the alien. So inside here, we just want to basically do, after we've destroyed both of these objects, we're going to do q.stage scene. And then we're going to stage the endgame scene. And then we're going to pass in 1, which will make it be above the current stage. And then remember, we're going to pass in that parameter called label. And we're going to say u1, since the player won in that case. Then we're going to do the same thing. I'm just going to copy this, and we're going to put this for when the player gets killed. And this time, it's going to say you died. And before I run this, one last thing we're going to do here is we have this set up. So we have our end game stage. We want to resize our container as well. So what we're going to do here is we're going to do container.fit, and we're going to do a margin of 20. So what that's going to do is it's going to resize that container to basically fit everything inside here and give it a margin of 20 around it. So now if we go ahead and run our game, you can see we've got our player and our enemy. Let's try and kill the enemy. And then it says you won. We can click play again, it resets. If the player dies, you died, you can click play again and it resets. Okay, so that's all that we're going to be doing for this course on our game, but I wanted to give you some ideas for some next steps you could take to go ahead and develop this game further and to help you learn more about doing HTML5 game development with Quintus. So one thing you might do is add some lives for the player. This is something that'd be pretty simple to implement. You could even make the number of lives show up in like the upper left-hand corner of the screen by making a smaller image that shows up there. Make multiple enemies or stages. This is something that you could definitely add to the game. Maybe create some new AI for a harder stage. Add power-ups. This might be fun. Maybe you add another component that is a souped-up gun that is able to do rapid fire, for instance, or has a bigger shot, or does some kind of special shot. Maybe it fires 2 shots at the same time. A start screen. We didn't implement a start screen, but most games have some kind of start screen. They don't just immediately start up. And then you could implement sound. We haven't covered this, but this is really, really easy to do with Quintus and with HTML5. And then finally, explosions. When we kill the enemy, right now they just disappear, but we could add some kind of animation and put an explosion on the screen that would make it look like that enemy exploded. Well, thanks for joining me on this course. We're at the end of this course now, unfortunately. It's a lot of fun building games. I hope you had a lot of fun with this course. I certainly did. I just love building games. And I hope that you've gotten to see what the Quintus game engine is like. And maybe this course has convinced you a little bit more that HTML5 is actually a viable platform for developing games. I was pretty amazed by what you can do with HTML5 as far as game development. It's really, really come a long way. And I just wanted to say that it doesn't matter if you use Quintus. The big thing is that there are so many different game engines out there right now that support HTML5, and it's just growing every day. So Quintus might not be the one that you end up settling on, but I found that it's a good one to learn. It seems like it's pretty easy to learn, and it's pretty useful. I really like some things inside of Quintus, like the components, but feel free to use another game engine if you want to. Once you have the basics down of creating a game and you've used one game engine, you'll find it probably a lot easier to try out other game engines. Well, thanks for joining me, and take care.